VAP5 states that g of x is equal to the integral of 2 to x of f of t times d of t with this given equation. And what it wants us to do is to sketch g of x. Now, translating this to paper, we know that an integral is the accumulation under a curve, so focusing just on the given parabola, we know that the accumulation from 2 to 1, which is going in the opposite direction, is about negative 2.6, and since both these values are negative, it becomes positive. And accumulation from 2 to 2 will be 0, and from 2 to 3, we see that's about negative 0.8. And to get from 3 to 4, we will add the 0.5 that we see here to our previous number, and this will be repeated until we get to 9, where our function ends. And now we can take these points that we've gathered and use them as coordinates when sketching g of x. And when we do this, we get this dotted line here. And this makes sense, as since this is an integral, our parabola should be the derivative of this cubic function, which it is. And part B asks us to evaluate h of x, as h of x is equal to the integral from 2 to 3x minus 5 of f of t times dt. And it wants us to find the derivative of h at 3. So using the fundamental theorem of calculus, we can know that we can plug in our upper boundary into t and solve that way. So we have h prime of x is equal to f of 3x minus 5 times the chain rule, which in this case is 3. And now we can plug in our 3 that we want and get f of 3 times 3 minus 5 times 3, which is f of 4 times 3. And going back to our graph, we can see that f of 4, which is our parabola, is 1. So we now plug in 1 right there, and this gives us h prime of 3 is equal to 3.